Good morning, friends. So, in the last few lectures, we started sharing stresses. So that's why today also I am continuing problems related with the complicated problems related with the sharing stress. So that's that may be I sections, H sections, and T sections. We'll today see these three types of the problems. So in the first problems, the combination is I section, and after that H section, and in the next problems, second problem is T section. So please note down today's first problem is steel beam of I section is 600 mm. It's 600 mm deep. Means this is overall. Deep means overall. Each flange is 250 mm wide and 25 mm thick. The web is 15 mm thick. The beam section is subjected to a force of 500 kilonewton. Determine shear stress distribution for the beam section is section first when the wave is vertical and second wave is horizontal. So this is given. So deep means overall. So first when wave is vertical means and distributions above the shear stress for this is neutral axis. So this is shear stress about neutral axis. So the overall 600 this is 550 because this is 25 and this is 25. This is 15. This is 250. So for calculation purpose or for we can simplify this as likewise. So this is overall 600 and this is B equal to small b equal to 550, small d equal to this is 250 minus 15 means 235 and this is again 250. So this is D, this is small d, V550 and this is capital D. So that's why first we will calculate moment of inertia about x-x axis because this is x-x and this is symmetrical about x-x axis means solid and hollow portion. So that's why you can take formula BD cube divided by 12 small BD cube divided by 12 equal to B equal to 250 D equal to 600 cube divided by 12 minus B equal to 235. This is 550 cube divided by 12. So this is 250 into 600 cube minus 235 multiplied by 550 cube divided by 12. 1.241 10 to the power 9 mm raised to 4 because this is moment of inertia. Next we request because formula SAY bar. So suppose this is first and this is second. Now, so first we will calculate shear stress above the, so this is junctions of flange and web. This is junctions of the flange and web. This part is the junctions above the flange and web. So just we are calculating just above shear stress above, just above junction of flange and web. So AY bar equal to area 250 into 25 multiplied by Y bar. So the centered distance from the neutral axis, 12.5 minus 300, and this is 287.5, right? So that's why yes, shear stress above, we can say above. So yes, a y bar divided by capital BI. S equal to shear force 500 kilonewton means multiplied by 1000, a y bar 250 into 25 into 287.5, and capital B equal to this is capital B just above, means width equal to 250, and this is 1.241 into 10 to the power 9 and divided by answers multiplied by 500 multiplied by 1000 multiplied by 250 multiplied by 25 multiplied by 287.5 divided by 250. So I am getting 1 point above the difference, that's why I am checking 1.241 10 to the power 9. Once again I will check 500 multiplied by 1000 multiplied by 250 multiplied by 25 multiplied by 287.5 divided by 250 divided by 10 to the power 9, right, divided by 1.241. So this is equal to 2.895 mega Pascal, and this is above. Now below means just below. So here's formula S A Y bar. So instead of the B, capital B, this is small b I. So that's why only change, rest of the 4 parameters same. So that's why here's 500 into 1000 multiplied by 250 into 25, 287.5. Instead of the 250, this is 15.241 10 to the power 9. So this 2.895 multiplied by 250 divided by 15, you will get this is 48.26 mega Pascal. So this is 2.895 mega Pascal and this is 48.26 megapascal, and this is symmetrical, so that's why this is same, because this is symmetrical. 2.895 megapascal. Now about neutral axis. So shear stress about neutral axis equal to, so that's why about neutral axis equal to SAY bar divided by BI. Now AY bar equal to, so please try to understand, above the neutral axis means both the section, so that's why AY bar equal to, so here's A1 Y1 bar plus A2 Y2 bar, so that's why A1 Y1 means this 250 into 25 into 287.5, and A2 Y2 bar means this part, and this is Y2 bar. So Y2 bar, because this is 550, means this is remaining is the 275. 275 divided by 2. So that's why, and this is 550 means 275. So here what you can take common, so nothing is common, so that's why 137.5 multiplied by 275 multiplied by 15 plus 287.5 multiplied by 25 . So once again I will check, this is 250 multiplied by 25 to 287.5 plus 15 into 275 multiplied by 137.5. Two 50 into 25 into 287.5 plus 15 into 275 divided by 137.5. 2364 10 to the power 6. So that's why shear stress above neutral axis equal to S equal to 500 multiplied by 1000 into 10 to the power 6 divided by B equal to again 15, I equal to 1.241 10 to the power 9 equal to . $63.49. I will check my answer. Yes. So this is maximum equal to 63.49 megapascal. So this is for when the wave is vertical. Now for second part, so this wave is horizontal. Horizontal means now H type. Otherwise, because we require that space for distributions of the shear stress. So this is 550 and this is 25, this is 25. Now this is 250 and this is 15. So this is neutral axis. Now distributions above the shear stress. We'll see. So H section, but this is hollow portion. So this is symmetrical. This hollow portion, this is not passing through the neutral axis. So that's why, for understanding purpose, can we modify? So for calculation purpose. So this is my own method. So please try to understand this. This is wave 15 and this is combinations of the two cross type. So this is 25, this is 25. So that's why this is total 25. All right. And this is overall 250. And this is wave. So that's why wave equal to this part equal to only 550. And this is 15. So that's why when the wave is horizontal, when the wave is horizontal, first see calculations about the moment of inertia. So how you can calculate the moment of inertia? So for simplifications about the moment of inertia, I modified these figures. So that's why this is one. This this is not 25. This is 50. So B1 equal to 50. D1 equal to total 250 and B2 equal to 550 and D2 equal to 15. Now this is passing through because we are considering likewise. So this is neutral axis. So this is passing through the both component. So this is say first component, or you can say this is second component. So that's why moment of inertia equal to BD cube divided by 12 plus D2 cube divided by 12. B1 equal to 50. D1 this is 65.2588 10 to the power 6 mm raised to 4. Move it up in inertia. Now shear stress above the junction, just above the junction of wave and flange. So here, just above means here. Yes, A Y bar BI, yes, equal to again 500 into 1000 AY bar. AY bar area 50 into total 250. So that's why remaining 125. Above the junctions means this. So this is equal to 125 minus 7.5, 117.5. So that's why 117.5 multiplied by 50 117.5 divided by 2. I will check. Right, because this distance also is to be considered. So that's why plus 7.5, because this distance is the total Y1 bar divided by B equal to 50, and this is 65.2588 10 to the power 6. So 117.5 divided by 2 plus 7.5 multiplied by 50, 7.5 5 again 50. Why this is double 50? Cancel, one cancel. Divided by 10 to the power 6 divided by 65.2588 divided by 50. So this is equal to 59.64 mega Pascal. Right. Now this is just below. So shear stress just below of the junctions, below the junction of wave and flange. So that's why here divided by 50. So multiplied by 50 and divided by 250. So multiplied by 50 divided by 250 means 11.928. 11.928 mega Pascal. Right. Now shear stress neutral axis. Now directly can I write S equal to 500 into 1000 in bracket. So we can write same 117.5 U into 50 into 117.5 divided by 2.75 plus now this area, so that is 5U50 multiplied by 7.5 and centroidal distance. So this distance equal to 7.5 divided by 2, bracket close. Now width equal to 550 and so this is 65.2588 10 to the power 6. So you have to calculate this. So 117.5 divided by 2 plus 7.5, 66.5 multiplied by 50 multiplied by 117.5 plus in bracket 550 into 7.5 square divided by 2, bracket close, equal to multiplied by 500 multiplied by 1000 divided by 550 divided by 65.2588 divided by 10 to the power 6. So this is equal to 5.637 mega Pascal. So that's why these distributions So this is about neutral axis 5.637 megapascal, and above so still it is less. So what we calculated, that is correct. So here's about neutral axis you got. Likewise, this is 5.63 and this is 59.64 megapascal, and here 11.928 megapascal. Because this wave is greater oh sorry so actually this means this wave is, so we did mistake here, this wave is here 600 because this is total, this is wave because we cut this, so that's why this is 600 means 59.64 multiplied by 50 divided by 600. So this is 4.97. So this is correct. .97 megapascal, and this is 5.63 megapascal. So this is correct. Why this is because we divided this is one part and this is in second part combined here. So that's why this is combination. So now this is correct. So we'll see the next problem is the T section problems. The T-shaped cross section. So please draw this distributions of the shear stress diagrams. So that's why your point will be clear. The T-shaped cross section. The T-shaped cross section of a beam shown in figure is subjected to a vertical shear force of 100 kilonewton. Calculate the shear stress at the neutral axis. Shear stress at the neutral axis and at the junctions of the web and at the junctions of wave and flange. Moment of inertia about horizontal neutral axis is, so for this problem moment of inertia is directly given, so no necessary of calculations about the moment of inertia. Moment of inertia about the horizontal neutral axis, the horizontal neutral axis is 1.134 10 to the power 4, 8 mm raised to 4. So this is T section. $200 50 this is again 50 and this is 200. So this is suppose positions of neutral axis. So distributions of the shear stress diagram. So in this problems, moment of inertia directly given. So no necessary of calculations about the moment of inertia. So that much part is no need to calculate, but this is unsymmetrical about x axis. So that's why we have to calculate new positions above the neutral axis. Suppose this is first and this is second, and if this is reference line. So y bar equal to A1 y1, A2 y2, A1 plus A2 equal to first area 200 multiplied by 50, y1 distance. So this is y1 distance from reference line, 50 divided by 2 plus A2 equal to 50 into 200 plus 50 plus 200 divided by 2, and this is divided by so this 250, 200 into 50. So by taking common, so this will get cancelled, and in bracket, so this term 50 by 2 plus 50 plus 200 divided by 2. So that's why this is 25 plus 50 plus 100 divided by 2, 175 divided by 2 equal to 87.5 mm. So this distance equal to 87.5. Now shear stress just above means here above the junction of wave and flange. AY bar equal to 200 multiplied by 50 into 87.5 minus 50 divided by 2 is 25. So this is 87.5 minus 25. How much? 87.5 is 67.5. No, 62.5. Right? So that's why above equal to capital BI. 100 into 1000, 200 into 50 into 62.5, B equal to 200 2.755 megapascal, and below equal to means here, so this is 2.755 megapascal, and here this is 2.755 multiplied by, this is divided by, so that's why here 200 and multiplied by 50. .022 megapascal. I will check my answer. Right. So this is 11.022 megapascal. Now about neutral axis. So this is 100 into 1000 A1 Y1, 200 into 50 into 62.5 plus, now this area equal to 87.5 minus 50, 87.5 minus 50. So this is depth equal to 50, and this is 87.5 means 37.5 divided by 2 divided by, this is B equal to 50 and I equal to 0. So that much, this is the additional, so that's why 37.5 divided by 2 into 50 multiplied by again 37.5 plus 62.5 multiplied by 200 multiplied by 50 divided by 50 . So this is 11.64 megapascal, and this is 11.64 megapascal. So this is your required shear stress distribution diagram. You can calculate this from bottom sides also, or otherwise alternate. Method for calculations of, so this part you can consider 100 into 1000 multiplied by area equal to, this is 87.5 means remaining equal to 112.5 multiplied by 50, and this is 112.5 divided by 2 and divided by 50 into 1.134 10 to the power 8. So same also you will get 112.5 multiplied by, or otherwise square, 112.5 square divided by 2 multiplied by 50 multiplied by 1000 multiplied by 100 divided by 50. So this is equal to is there any I did mistake? So this is exactly we are getting 50% less. So we'll see this second methods in the next class. So that's why today I will stop here and we'll see the remaining portions in the next class. Thank you.